Listen to Kovai Vani. Enjoy the podcast by our enthusiastic young residents. Kovai Care is the best place to retire.
Welcome, friends. Today we're going to bring you a discussion with Mr. Hariharan, who has extensive experience in the automotive industry in materials, corrosion resistance, supply chain, and research and development with leading companies in India. Let's begin. With the advancement of technology and research in the auto industry, how do you see the future of the industry in terms of materials, sustainability, and automation?
Thank you, sir. My pleasure and honor to be part of this podcast. Well, the automotive sector is considered quite important for a country's economy and trade. It shapes the industry, shapes the communal and individual life. Technology is a key element for the survival and growth of any business, so too the automotive industry. With the advancement of technology, nano-sized materials of particle size as low as 10 raised to minus 9 meters, smart materials like the shape memory alloys, advanced composites, graphene, ultra high strength steels, advanced high strength steels are some amongst the material fraternity that have either made or are about to make a strong impact in the Indian automotive arena in the near offing. Nanotechnology is being explored for applications related to corrosion protection, for applications in chassis and tires, in engines and transmission system, for reduction in friction amongst moving parts, for improving the fuel injection, for reduction in exhaust emissions, etc. Then we have graphenes, a monolayer of carbon atoms, which is slowly gaining use in automotive applications to primarily enhance the air impermeable properties of the inner liner of the tires, to reduce tire weight, very important, and also provide better grip and reduce rolling resistance. Also, graphene silicon anodes are used in lithium ion batteries for electric vehicles to increase energy density, power density, and improve battery longevity. Very important given the fact that we are already launched electric vehicles. Far as automation goes, it simply allows tasks to happen automatically. Since a staggering number of tasks at the vehicle assembly are repetitive, technological advancement goes a long way and can be easily automated. Handling everything from welding to assembly to painting, robotic automation is indispensable on the automobile shop floor. It is not to replace human labor, but to augment it by offloading repetitive mundane tasks to machines.
How much is the contribution of materials to fuel emission, ease of travel, climate change, and electric hybrid vehicles?
It has also pervaded car financing and distribution, going from physical robots to digital bots, taking advantage of robotic process automation with bots, handling customer queries in the call centers of financing companies and software robots at dealerships, scheduling service appointments, sending alerts, running diagnostics, and even selling cars. On sustainability, I believe that if ever there was a time for the Indian automobile industry to take stock and recalibrate its sustainability strategy, it's now. The pollutants emitted by an automotive engine during the combustion process are known as fuel emission. Out of the greenhouse gases emitted like carbon dioxide, carbon monoxide, hydrocarbons, and soot, carbon dioxide is a major pollutant. Usage of cleaner fuels, fuel efficient vehicles, use of electric vehicles are ways to reduce carbon emissions. There are some clean fuels made from cellulosic biofuels that bring down the emissions by up to around 80% in comparison to carbon fuels, though this may not be totally viable. What could be viable are the aluminium intensive body, which we shall be discussing shortly. Now, using lightweight materials goes a long way in reducing carbon dioxide emission. It's interesting to note that a weight reduction by around 300 kg translates to fuel saving of around 3000 liters over a lifetime of a vehicle. Now, consumption of 1 liter fuel translates to around 2 kilograms of carbon dioxide emission. Hence, consumption of around 3000 liters of fuel should translate to around 6000 kilograms of carbon dioxide emission. So, maximum saving in vehicle comes from its body. Hence, as stated before, aluminum intensive body could be the right answer, or maybe high strength steels with low density may help to some extent, though definitely not as much as an aluminum intensive body. Due to small size of particles in nano range, the chemical and physical properties can be altered to improve the overall properties of conventional material. Increased surface area of the metal nanoparticles result in significantly enhanced reactivity. This aspect is now being introduced in catalytic converters for more effective conversion of greenhouse gases, thereby resulting in reduction of vehicle emission. Electric cars and buses use electricity as fuel. They produce lower emissions than the vehicles running on internal combustion engines. On the future of electric cars in India, I personally think it is not that promising. Reason? There are more than 20 million cars in India which are running on fossil fuels, that's petrol and diesel, and same number is steeply increasing every day. One cannot just dump these many vehicles and jump fully into the concept of electric cars. Maybe newer and newer alternative fuels can be used still in the same vehicles in place of the petrol and diesel fossil fuels. Regards ease of travel, one would want one's car to take off quickly, also come to a stop quickly. This can happen if the vehicle has materials with higher kinetic energy. Aluminum with a high kinetic energy compared with steel is a ready answer. Also, due to its enhanced crashworthiness, vehicle with aluminum shell is a good buy far as ease of travel is concerned. As for climate change, burning fossil fuels in cars releases primarily carbon dioxide, one of the major sources of greenhouse gas emissions. As these gases build, they trap heat into the atmosphere, causing climate change.
In order to reduce emissions, the automotive industry as a whole is working to reduce mass in passenger vehicles in order to reduce energy consumption. One way to reduce mass is to introduce lightweight materials in the body of the vehicle. How far are we ahead in this technology?
A popular strategy adopted by automakers and different OEMs is to reduce a vehicle's weight, which can significantly reduce fuel consumption and carbon dioxide emission. A lighter car consumes less fuel because it needs to overcome less inertia, reducing the power required to move the vehicle. Current material trend in India is around 67% of ferrous materials, around 9% each of aluminum and thermoplastics. Aluminum used in automobiles is gathering steam, while the automotive industry is racing to reduce the weight of vehicles in order to meet the proposed emission standards. Well, multi-material makes combining various types of advanced high-strength steels, aluminum alloys, carbon fiber, magnesium, plastics, etc. are few options that remain open for a lightweight vehicle. However, given the cost and performance targets, aluminum intensive body and steel, that is advanced high-strength steels and ultra high-strength steels, could be dominant in the future, with each making up around perhaps 20 to 30% of a vehicle's weight. While aluminum shall remain the dominant material in big vehicles, advanced high-strength steels is expected to maintain dominance in smaller vehicles. Well, removing or swapping heavy electrical components, replacing glass windows with polycarbonate thermoplastics, lighter body panels on the vehicle body could be the other answer for a lighter body. On the powertrain aggregates, that is engine and driveline, use of lightweight castings like aluminum and magnesium alloys, metal matrix composites, very important, picking up very gradually in India, which by virtue of the low density, high strength to weight ratio have the potential for replacing the heavy cast and ferrous aggregates. Further options are the near net shaped sintered materials, hollow constructions, glass filled thermoplastics, etc.
Corrosion plays a major role in every aspect of life. How do you tackle corrosion in an industry that faces all climatic conditions, severe heat, extreme cold, and harsh rains and cyclones?
Corrosion is a widely encountered issue in the automotive industry. To account for and prevent this problem, vehicle manufacturers try to devise various methods to delay corrosion. However, tackling this menace amidst diverse and adverse climatic conditions that vary from place to place can be quite challenging. Corrosion management being one of my core areas, I would request to briefly share some of my experiences in strategizing and chalking out a robust corrosion management system, a ready reckoner for any organization. To obtain a realistic data of vehicle corrosion over a stipulated period, we conceptualized corrosion survey of vehicles at our dealerships pan India, covering areas with diverse climatic conditions. Based on diverse climatic conditions within the country, a vehicle level corrosion test cycle was designed. Data from the survey was compared with that from the vehicle level corrosion test to draw a correlation. Once done, vehicle level tests were repeated on few more prototypes to generate a sustainable data on the degree of corrosion, areas of corrosion, types of corrosion on which surface protections were revisited. We further went ahead to frame a corrosion warranty over and above the generic vehicle warranty, a marketing strategy for our vehicles.
What, in your opinion, are the emerging innovations in materials to accelerate the progress of making vehicles that are light, safe, and fuel efficient?
Artificial intelligence technologies such as machine learning, deep learning, and computer vision find applications in robotic automation within the automotive industry. These guide self driving cars, manage fleets, assist drivers to improve safety, and improve services such as vehicle inspection or insurance. Artificial intelligence also finds applications in automotive manufacturing, where it accelerates the rate of production and help reduce costs. Machine learning is a subset of artificial intelligence which uses statistical methods to enable machines to improve with experiences. Deep learning is a part of machine learning which makes the computation of multi-layer neural networks viable, takes advantage of neural networks to simulate human-like decision making.
What are the major differences in materials and technology for cars and goods carriers?
Well, between passenger cars and commercial vehicles, construction of a passenger vehicle is monocoque in type, meaning the construction is in the form of a single shell. A car body has two distinct safety features: an impenetrable safety cell or occupant compartment and dedicated crumple zones that ensure vehicle crashworthiness. The safety cell must withstand extremely high loads and minimal deformation of intrusion. The dedicated crumple zones, however, are optimized to collapse in a controlled manner, absorbing maximum amount of energy possible. In commercial vehicles or goods carriers, the chassis formed by frame structure carries the vehicular operational parts like engines, transmissions, suspension systems, fuel tanks, batteries, wheel suspension, etc. Commercial vehicles weigh manifold times as much as a passenger vehicle. They are taller, have high ground clearance than cars. So, to prevent sliding of lower riding vehicles beneath truck trailers, strong underrun protection devices are attached to commercial vehicles on the vehicle front, rear, and sides, not required in passenger cars. Since the ground clearance in the case of commercial vehicles is relatively high, it makes sense not to spend money on underbody protection, anti-stone chip resistant coatings that come at a high cost. In the case of passenger cars, the coating is mandatory. Chassis frames in commercial vehicles are shaped like ladder with two long and heavy beams supported by cross members that run in transverse direction. The ladder chassis is quite heavy and finds use in vehicles that need to tow heavy stuff around. Since there is no need of dedicated chassis frame in cars, there is substantial weight and cost saving for cars. Commercial vehicles are sold as chassis frames fitted to the vehicle cab and make sense to have the chassis frames as attractive as possible to give a good paint. This, of course, is redundant in passenger cars. The list is endless. There are many differences, and the materials, treatment, and technology vary accordingly for these two types of vehicles.
Finally, Mr. Hariharan, is Hariharan an auto freak or does he have other passions?
As a material scientist having worked in the automotive sector for decades, I have no doubt developed a deep fascination. However, my passion was, is, and shall ever be music. Music to me is a religion. A lover of old Hindi film songs of the late 60s, 70s, and 80s, I endeavor to practice at least for an hour each week on my musical system. I would request to build few lines from an old Hindi song slightly modified, translation of which runs as follows. Let's take you to a land bereft of sorrow, bereft of tears, where abound love and only love. That place known as Kovai Chinmayam, a place that knows no enemy. Let's all walk together on this path in togetherness. चल के तुझे मैं लेके चलूं एक ऐसी गगन के तले, जहाँ गम भी न हो आंसू भी न हो, बस प्यार ही प्यार पले। चल के तुझे मैं लेके चलूं एक ऐसे गगन के तले, जहाँ गम भी न हो आंसू भी न हो, बस प्यार ही प्यार पले। कोवै चिन्मयम के तले, कोवै चिन्मयम के तले, कोवै चिन्मयम के तले। Thank you.
Thank you very much, Mr. Hariharan, for highlighting issues that you consider relevant in the automobile industry. Thank you.
Thank you and stay tuned.